Next up, we have the founder of Flutter Gems, Ashita Prasad, a true Flutter gem herself. She is the founder of Flutter Gems and a visual package a discovery platform, and the co-creator of API Dash, an alternative of Postman made in Flutter. Ashita has graced over 30 plus international conferences with her presence including Flutter Vikings, Flutter Global Summit, SkyPy, PyML, and many more. Today, she is here to enlighten us on building high-performance apps by mastering .devtools. Ready to level up your Flutter game, folks? Let's give a hearty welcome to Ashita Prasad.
So, hello everyone. I'm Ashita, and today we'll be talking about DevTools and how you can make your Flutter apps faster as well as more reliable. So, just to give you a brief intro about myself, I am the founder of Flutter Gems, which is a visual package discovery guide which helps you find packages for your requirements. I hope a lot of you must have used it. That's great. I also run this Discord server, which is primarily for Dart, Flutter, as well as other open source technologies. So in case you have any doubts on any open source technology, any of your projects you are facing issues, you can come ask questions. There are a lot of people who will help you out, and you can have engaging and meaningful discussions here. Uh, I am also working on API Dash, which is the first open source API client which has been completely built using Flutter from scratch. And it's an alternative to Postman. So do give it a try if you use APIs. And you can check out the project at api-dev. So well, all of you use Flutter here. And we have some wildly successful Flutter apps in the market. You have apps like Dream11, GPay. How many GPay users? Yeah, a lot of you. So now, if while using GPay, why is GPay so useful? Because it gives you a very high performance. And as Vivek discussed, the importance of having highly performant apps if you want a good business. So, well, how do we ensure that while building, we can have high performance apps? We use something called Dart DevTools. So, what is Dart DevTools? It's a pre-packaged suite of application APM tools and debugging tools that you can use. These are some of the DevTools in the DevTools suite. One of you even won a swag for it. So you have Flutter Inspector, Debugger, Logging View, Performance View, CPU Profiler, Memory View, Network View, and App Size Tool. So today we'll be looking at CPU Profiler, Performance View, and your Network View. So this will be a demo-led session, so I'll just quickly tell you how you can launch DevTools in VS Code. You have to select a target platform. That can be any of the platforms like you see on the screen. It can be Mac, Android, anything. You then have to hit run to be able to run the app, and you can launch DevTools. So you can do that using two ways. One is using the VS Code status bar, and like you can see here. And the second is using the command palette. When you click on it, this opens up, and you can select your DevTools. Now, there are two ways you can open DevTools. You can do it inside Visual Studio Code, like you can see here, or you can use it in a standalone web browser. So this is how it looks when you do it on a standalone web browser. So now, quickly let's get to understanding how we can use CPU Profiler to improve your app's performance. So well, we discussed a lot of stats when Vivek was also discussing about performance. Now, 80% of people who download an app, a study states that they immediately delete their app. They never come back. They're not going to give you a second try. And what is the reason for that? The reason is performance issues. And well, what is the solution? The solution is profiling. And what is profiling? Profiling is a performance engineering method which is used for analyzing the CPU resources that are consumed by a code. And well, how can you do profiling in Flutter? You use CPU profiler. So, as the name suggests, CPU profiler will provide insight into the CPU usage of an app. So, we'll quickly do a small example where we will visualize the Mandelbrot set. So, the source code is available on GitHub, and we open the project in VS Code. You launch CPU profiler view in VS Code, and you have to use an actual device. Now, the question is, why will you use an actual device? The reason being to be close to a real life scenario. Because if you test on your MacBook Pro and your user is using, say, a Vivo or a MI, a low-grade phone, they won't have the same experience. And as developers, we are always on MacBooks, which is why you need to use an actual device. So again, this is how you choose an actual device using the VS Code status bar. You can also use your desktop in case you are building it on desktop. Again, why profile mode? There are, apart from the iPhone Pro example, the MacBook Pro example, and your Vivo example, the reason is profile mode. In your debug mode, you have a lot of additional assertions or functionalities that are there, which tend to bog you down. Secondly, your profile mode runs on AOT, that is ahead of time compilation, whereas your debug mode runs on JIT. So if you run debug mode, you will get jank when actually you won't have a jank because of the way they are executing the code. And third is to be as close as possible to your actual users. So again, to get started with CPU profiler, you have to open Dart DevTools. You have to click on this CPU profiler tab when the window opens up. And when you open it up, you'll find that there are 3 primary buttons. You have your record, you have your stop, and you have your clear. So it's pretty easy to use it. So when you do record, it will start your CPU profiling. When you click on stop, it's going to stop it. And when you clear, it will clear all the CPU usage data that it has recorded. There are some additional options that are again very helpful. We have the profile app startup option. Now what this does is it will load all your CPU sample that have occurred before even your first Flutter frame was drawn. And whenever you have a case of a delay in an app startup, this is the tab that you have to come and see, because it's going to help you identify the underlying functions that are causing those delays. The second is load all CPU samples. So this loads all CPU sample data even when you have multiple isolates spawned. The third is profile granularity. Now what granularity means is how many CPU samples do you want to see per second. So the default is set as medium, which means you want 1 CPU sample per 250 microseconds. You can have it a low granularity, or you can even have it set it as high granularity, where you want 1 CPU sample per 50 milliseconds. This is again depending on the business use case that you have. So now we'll be looking at two scenarios. One, where we'll be running the entire Mandelbrot set on a single main isolate. And second, where we'll be using parallel processing and running it across multiple isolates. So we are going to run the app. And here you can see we are recording our CPU usage using the record button. So always remember, you have to first execute your app, and then you can start recording CPU sample data so that you can see what issues are there. Here, we can select the number of isolates and click on the Launch Explorer on the app's home screen. When you do that, you will see that your app now opens up, and we have the Mandelbrot set which is being computed and the visualization screen. You can see the Mandelbrot visualization on the next screen. Just a second, there is some technical issue. Yes. So this is the CPU usage data that we get. So you can see there are 3 tabs here: bottom up, call tree, and the CPU flame chart. Now, if you closely look at bottom up, what do you see at the top? Anyone? You see a function that is using almost 75% of the total usage. So what this does is bottom up will give you the longest running function at the top of the table. And you can see the execution time here of these functions, both in terms of absolute numbers as well as relative in terms of the percentage of the total runtime. So when you look at this, what is the main problematic function here? It's Mandelbrot iterations, which is taking the most amount of time. So now what we are going to do is we are going to go deeper and see if we can improve it. This is a second way of seeing the same data. It's the call tree tab, and what it does is it will give you a top-down representation of the entire call stack. So you can see what all functions and where the entire call stack of that thing you can see here. And in this way, it is a little opposite to the way we see in bottom-up approach. We then have the CPU flame chart, and here you can see your CPU usage is presented as a stack of method calls, where each method is calling the method below it. And here the width is very important, because that width of the method is actually denoting its runtime. And you can see that there are different colors here. We have lavender blue and also your pale orange. Any guesses why is it so? So well, all your core Dart and Flutter libraries are in lavender blue, and all your third-party packages are in pale orange. So whenever you are using packages, external dependencies, this can be very helpful to see if any of them are causing performance issues. So this is how it looks like. You can see these, the width basically indicates the runtime. And now we'll quickly identify the CPU. We've already identified the CPU intensive method, right? So we'll quickly go and see into the function. So if you look, this is the function that is taking the longest time to execute. And the reason being that render data is calling this iteration for each and every pixel. Now, how can we improve performance? We can do that using 2 ways. We can reduce our time complexity, for which we'll have to improve the entire algorithm as such, or we can do parallel processing. That is something that we'll be doing now. So we'll quickly create more isolates. And we'll repeat the entire process that we did. And let us quickly validate our observations. So if you see, iterations is not taking the most time here. And why is that? Because if you closely look, it's not being executed in the main thread. We have pushed it to the isolates. So what we need to do is we need to check the isolates. And we can do that using the load all CPUs sample options that was there. Again, if you see the bottom-up table and isolate number 2, you can see that actually Mandelbrot iterations is taking the most amount of time, again, across all the 4 isolates. But because we moved from a serial execution to a parallel execution, we gain a performance improvement of around 2.5 times. So I'm short on time, so I'll quickly cover network view. So well, network, why do you use it? Because, well, APIs, they are everywhere. And to find out if they are causing any issues, you move to the network view. So again, this is how you can launch a network view. And these are the controls that you can see. We have pause, we have resume, and we have clear. So by default, your network logging is always on. When you click on pause, they'll pause it, and you can resume it by clicking on the resume button. So here you can capture both your REST and WebSocket views as well in the network view. And on the left, if you see, you get a detail of all the requests that are going. You have your request HTTP method, you have your URL, you have your response status, the content type of the response, duration. And on the right, you can see the details, response of the selected request that is there on the left. And when you do that here, if you closely notice, you can see that there is a breakup of the request sent time. You have your total time, that is for which the request was sent. You have your waiting time, and you have your content download time as well. Again, you can also view all the request and response headers of the selected requests. They also have a tree view for your JSON response. And in case your response is an image, you can view the response body and preview the image directly here. And in case you want to basically look more into the API, you can always copy the curl, and you can investigate it in your favorite API client. So I am short on time, so I'll skip performance view. And I'll just talk a little about the future of Dart DevTools. So if you have been following the news, Dart recently launched the DevTools extensions framework, which allows package authors to build powerfully tightly integrated tools that leverage their existing frameworks and utilities from DevTools and help developers by making their lives easier. So you can try out some extensions like provider DevTools extensions, which will show the state of your application in Flutter DevTools. You can try out a role DevTools extension, which will enhance your UI test development experience. And Drift, if you use it, you can use it to see how your database is working. So that's it from my side. If you have any questions. So if you don't have any questions, we can close. Yeah, please go ahead. I'm sorry, I can't hear you. Yeah, so when you use isolates when when you have a single when you do a serial operation and there is one function which is taking the most amount of time. So like if you see in the Mandelbrot iteration example that I showed you, there was this one function iteration which was taking the most. But if you execute it parallelly across 4 isolates, this computation gets split into 4 different paths. Then your entire app will become faster. And you can see how doing that, we got an improvement of more than 2.5 times. No, yeah, that depends. If you have a bottleneck, if you there are 3 APIs say, and 3 of them are bottlenecks, then you don't want to put them serially. Like when you do a serial operation, you don't want a lot of bottlenecks because then your process is going to get very, very slow.
Hello. Yeah, here.
Yeah.
So I saw that you are using MacBook, and MacBooks are the best computer available.
Yes. Yeah. Yeah, so that's because right now, yeah, Flutter DevTools, you need a minimum 8 GB of RAM to be able to run it, to be able to run it smoothly. And right now, the reason it was lagging, because I'm also sharing screen and I'm running videos on Keynote, which is extremely like computationally intensive, and that's why it was lagging.
So
Yeah.
what are the cons for running multiple isolate threads?
See, this running a single isolate or multiple isolate is basically an architecture decision that you have to do. There are no cons or pros are there because you're going to get good performance. But if you unnecessarily split things parallelly when you don't need them to be, you might actually be hindering your performance.
So it depends on device also, na? Like for example, if I'm using an iPhone or if I'm using a Samsung low-end device. So
Yes.
running multiple threads on an iPhone is easy, na? The phone will
Yes, agreed,
support,
agreed.
but the low-end device will not
Yeah, that's why
cooperate.
whenever you test, you try to test it in profile mode, that I said. You don't test it on your MacBook Pro. You test it on a low-end device. And it again depends on who your users are.
Okay, thank you.
Hello? Is there any
Yes.
way to find memory leaks using DevTools?
Way to find? Sorry, I didn't get it.
Memory leak.
Yes, you have a memory view tool. You can actually go through it. You can find all the memory leaks that are there. I couldn't cover it because I was short on time. Yeah. So in case you want to read detailed articles on other DevTools also, I have written a Medium series. The Medium channel name is Flutter Gems. So you can read in detail about all the DevTools that are available. Cool. Thank you guys. If you have any questions, you can reach out to me on my socials.